Hi there. This video will be choosing which graph we can use to solve this physics question. Because some students, when they look at the question, they don't even realize that they need to use a graph. And at O-level, for the O-level syllabus, the equations of the motions are not being taught. So one of the best ways to solve this question is to use these motion graphs. So which graph should we use? It could be either the distance time graph or the speed time graph. Now let's do a short little recap first. Now for a distance time graph, let's say for example, if your distance time graph looks like this, all right, you notice that the gradient is constant. So the gradient is calculated, by the change in y divided by the change in x. Or another way to look at it is rise, I'm sure you've heard of this, rise over run. So the gradient actually represents the speed. So in this case, you can see that if the gradient is constant throughout, which means that the speed is also constant. So the gradient of the speed time graph represents the speed. Okay, so this is something that we have to remember in order to solve the question. Now, let's say, for example, if you have a graph for speed that looks like this is not a constant speed graph, correct? Because if it was a constant speed, it would be a horizontal line. So in this case, you can check for the gradient, which is change in y divided by change in x. Or you can also look at rise over run, but you can tell that the speed is increasing, which tells you that it's accelerating. So this, for speed time graph, the gradient represents the acceleration, or it can be deceleration as well. Okay. Now the speed time graph actually tells us even more information, because we can look at also the area under graph. So the area under graph will give us the distance traveled. So the area under graph represents the distance traveled. So as you can see, what are the informations that you can get from the different graphs? All right, let's move on to the question itself. Now, I always tell students that when you are looking at a question, it might actually help if you were to draw a very simple diagram to help you understand the question. So a car was traveling at 25 meters per second, approaches a traffic light, and when the traffic light turned red, he took some time to react, which is 0.5 seconds. So during the 0.5 seconds, while he was still considering whether he should brake or not, he's still traveling at the speed of 25 meters per second. So which means that he's traveling at constant speed for 0.5 seconds before he steps on the brake. So once he steps on the brakes, he will be decelerating, he would slow down. And the deceleration is given as 12.5 meter per second squared. So this is the average constant deceleration that the car is actually moving at, so that he can stop before the traffic light. Right. So now the question is actually asking, what's the total distance, what's the distance traveled from the moment he saw the traffic light to a complete stop? So which means he's looking at the distance from here all the way to here, assuming he stops right at just at the stop line at the traffic light. So this is the distance that we want to calculate. Now, let's try using the distance graph and see if it works. So given that it was traveling at constant speed, which means there will be a constant gradient for the speed distance time graph, which means it will probably look something like that, maybe. Yep. Okay, so it was traveling at a constant speed, which means that the distance is increasing at a constant rate for the first 0.5 seconds while he's still thinking about it. okay? And after that, he decided that he should brake. So the speed will be decreasing. So how should we represent deceleration on a distance time graph? So recall, the gradient of the distance time graph represents the speed. If it is decelerating, that means the speed is decreasing. So when the speed is decreasing, how should the graph look like? So you may pause the video and perhaps try this part on your own. Well, hopefully you have done so. Now, if the speed is decreasing, that means my gradient should be from steep to gentle. So imagine a hill, steep to gentle, meaning that my graph would look something like this, and it will go this way. Okay, so from steep to gentle. Let me show you here. A steep gradient to a gentle gradient. So this is a large gradient, which represents a larger speed. And this is a gentle slope, gentle gradient, so which is a lower speed. So this graph now represents deceleration. But how do we fit the numbers in? So as you can see, they tell you that at first it's moving at 25 meters per second, which means that the gradient here for the first 0.5 seconds is 25 meters per second. So in order for the gradient to be 25 meters per second, the distance must be 12.5. Okay, if you don't believe, we can calculate the gradient. So the gradient for the first 0.5 seconds would be 12.5 divided by 0.5, and you get 25 meters per second, right? Okay. However, I wouldn't be able to fit in my deceleration value of 12.5 meters per second subsequently, right? So maybe distance time graph isn't such a good idea. Okay, let's try using the speed time graph to see if we can solve this a little bit better. So the first 0.5 second is traveling at constant speed. So constant speed means that it's going to be a horizontal line. Okay, for the first 0.5 seconds, yeah, let's do it here. I'll try to match the top graph. So for the first 0.5 seconds, okay, and then subsequently he steps on the brakes and he will decelerate. So he will decelerate at a constant rate because it's at 12.5 meters per second squared. So it will decelerate to a stop. So let's put in the numbers into the graph. So it was traveling at 25 meters per second. So I could put it here, that's great. I do not know the time, okay, but I do know the gradient because the gradient of the speed time graph gives you the deceleration. So that means my gradient would be negative 12.5 as given in the question. With the gradient being 12.5, I will be able to know how long it takes for it to come to a stop. So because it will be rise over run. So let's try. So that means 12.5 is equals to 25 over the time taken. So therefore, the time taken for it to come to a complete stop would be 2 seconds, which means that this time here would be 2.5. Okay, now with all this information, it looks very promising. So we are able to calculate the distance traveled by using the, you're right, area under graph. Okay, so the area under graph, it's here. Okay, let's show. So this is the first 0.5 seconds where it was traveling when it's reacting, and this is the part whereby it's braking. So the total distance it takes to stop will be this entire area here. And let's try to calculate the area under graph. So the area under graph represents the distance traveled, which is half times the sum of parallel lines. So I have this parallel line here, 0.5, and 2.5. So I will have 0.5 plus 2.5 times the height of the trapezium, which is 25. Okay, so over here, I will have, so if you press your calculators and everything, it would be 37.5 meters. So he took 37.5 meters to stop the car completely. So in this case, you can tell that speed time graph is really useful because you could fit in the number of the acceleration inside, because the acceleration is represented by the gradient of the graph of the speed time graph, and the area under graph of the speed time graph would give you the distance traveled. So in this case, the speed time graph is actually a lot more useful. So I hope this video helps and you could try this similar questions on your own. All right, thank you.